Good morning, grade 10. How are you today? I hope you are fine. Today we will start with chapter or lesson 6, angle identities. Let's start with the first properties of the trigonometric identities that we called it negative angle identities. Now, here, if we have this unit circle, and if we have this point B, that its coordinate is cosine sine, Q is cosine negative theta sine negative theta. If I start from, wait. If I start from here with counterclockwise, I will say here, in this point, the coordinates of it is cosine and sine. And if I'm starting from here, I will say it is cosine negative theta because I'm talking about negative here and sine negative theta. Now, as you noticed here now, P is a reflection of Q. And since P is a reflection of Q, so around X, or reflection above the X axis, so here the sine of theta, or sine of negative theta, because it's reflect around X axis, it's equal to negative sine theta. So negative sine theta is sine negative theta, or I can say sine negative theta is equal to negative sine theta. Like as an example, to memorize it, just remember that I can put negative outside the sign. Sine negative theta is negative sine theta. And but here for the cosine, it will be the same without make any reflection. So because of that, I can say also the cosine theta is the same as cosine negative theta. So for the sine of negative theta, I can put the negative outside the sign. But for cosine theta is the same as cosine negative theta, like I can drop off the negative sign because it doesn't mean any things for me. I mean, cosine theta is the same as cosine negative theta. Why? If you try from here as an example, cosine negative 90. Sine negative 90 is what? It's negative 1. And cosine 90 is 1. So look here. I will now tell you how. Sine, I know that sine 90 is 1. It is here. And negative 90, it is here also. And sine negative 90 is negative 1. Now, is sine negative 90 is negative sine 90? As we said here, sine negative 90 is negative sine 90. Now, sine 90 is 1 times negative is negative 1. And sine negative 90 is negative 1. So yes, this is correct. So the first angle identity I can use that sine 90 is, negative sine 90 is the same as sine negative 90. It's about cosine now. If you try cosine negative 180 here, cosine negative 180, it is here. What is the cosine of it? It's negative 1. Negative 1, yes. And cosine 180 is what? Come here. It's also negative 1. Since negative 1 is equal to negative 1, so I can say that cosine negative 180 is equal to cosine 180. That's mean cosine negative theta is equal to cosine theta. These are the second angle identities. I will repeat. I can put the negative outside. Here it's negative theta is the same as theta without put the negative sign outside. Now tan negative theta is negative tan theta. Look here, as we said here, the x coordinate is the same, but the y coordinate is flipping about x-axis. So here is the same for S and R. Since S is the reflection of R, so tan negative theta is equal to negative tan theta as the same of sine. So tan and sine is the same. I can drop the negative sign, also I can put the negative sign outside. El cosine, no, I can drop it outside. The second properties we are talking about today is cofunction identities. Did you remember in lesson 1 or 2 when I told you that sine 30 is the same as cosine 60, and I told you it's equal half, and cosine 30 is as the same as sine 60, which equals square root of 3 over 2. From where I bring these numbers? How can I know them? From things we call them cofunction identities. Let's start with the first one now. Look here. Cosine, let's change the color please first. Now, sine pi over 2 minus 60, okay, is the same as cosine 60. If I use this property or this identity, pi over 2 minus 60 is a cosine 60. Pi over 2, which is 90, minus 60 is 30. So sine 30 is equal to cosine 60, which is, I said it here before here. That's why I told you that sine 30 is equal to cosine 60, which is equal to 1. What about now the second identity now here? Let's try cosine pi over 2 minus 60 also is equal to sine 60. Here, cosine pi over 2 minus 60 is equal to sine 60. Cosine pi over 2 minus 60, I mean cosine 30. Does it equal to sine 60 according to this identity? Yes, and as I said before, it is square root of 3 over 2. And the last one here, tan theta, sorry, I'm so sleeping. Tan pi over 2 minus theta is cotan theta. How? You divide sine pi over 2 minus theta. Oh, let's first use everything here. If you divide sine pi over 2 minus theta over cosine pi over 2 minus theta, what you'll get? Sine pi over 2 minus theta is cosine theta. And cosine pi over 2 minus theta is sine theta. Now, sine pi over 2. I'm sorry, sine over cosine is tan. And pi over 2 minus theta. We know before that sine over cosine is tan. And cosine over sine is cotan theta. This is that why tan pi over 2 minus theta is equal to cotan theta. Let's now go to problem number 1. Here we have to verify an angle identities. I want you now to verify that sine theta minus pi over 2 is equal to negative cosine theta. Let's start now with the term to the right, to the left. Sine pi minus, ya Allah, sine theta minus pi over 2 is, now, sine theta minus pi over 2. If you keep sine as it is, up here, sine. Now, pi theta minus pi over 2, like b minus a. Is it the same of negative a minus b? Yes. So, sine theta minus pi over 2, as I said in this one, we know here in the sine pi over 2 minus theta, we know that in the sine pi over 2 minus theta is cosine theta. Now, sine, can I use sine theta minus pi over 2? Yes, but here it will be what? Negative cosine. Now, so I will repeat sine, because I delete everything, sine pi minus theta pi minus pi over 2 is the same as sine pi over 2 minus theta. But here is not the same. We have to put a, I will give you another color. I have to put now an negative sign. Why? Because b minus a is negative a minus b. So if I want to change its order, yes, I can. Theta is the last and pi over 2 is the first, but so you have to put negative sign. Now, if you go now to this one here, I told you that sine negative theta, I can put sine negative outside. So here, can I put the negative sign outside? Yes, it will be negative sine pi over 2 minus theta. Now, negative sine pi over 2 minus theta. If you go back now to here, sine pi over 2 minus theta is equal to what? This one is equal to what? Is equal to cosine theta. And keep the negative sign outside. So it will be negative cosine theta, which is what I want to prove. Now go to get it one here. Cosine theta minus pi over 2 is equal to sine theta. I want to prove that cosine pi theta minus pi over 2 is equal to sine theta. Now, cosine pi minus theta minus pi over 2 is, can I change its order? Yes. I don't know, in the middle. It is the same as cosine. Now, if I change its order, I can, as I told you, yes, sure I can, but I have to put what? A negative sign. Thank you. Now, where's the arrow? I'm sorry. I can put now a negative sign. Now, I told you before that for cosine, especially for cosine, the negative sign cannot put it outside. I will drop it. So drop it. So it comes as cosine pi over 2 minus theta. Now cosine pi over 2 minus theta using this identities is equal to what? To sine theta, which is what I want to prove. Now here, page 940, exercise number 7. I want you now to prove that cosecant theta minus pi over 2 is equal to negative secant theta. Now, cosecant is what? Is 1 over sine. But here is not cosecant theta. Here I have pi minus theta minus pi over 2. Now, then after that, which equal to 1 over sine. Now, can I change the order? Yes, I can say it is pi over 2 minus theta, but I have to put what here? I have to put the negative sign. Bravo. Then, can I put the negative sign outside in the sign? Yes. So it goes like 1 over negative sine of pi over 2 minus 0. Now, then after that, 1 over negative sine pi over 2 minus theta is the same as cosine theta. Bravo. Then 1 over cosine is secant of theta. And this is, we have here, negative sign. Number 11. Tan theta minus pi over 2 is equal to negative cotan theta. Tan theta minus pi over 2. Can I change its order? Yes, I can say it is tan pi over 2 minus theta. But here, what did we have? So the first step, in general, change the order to prove. Then tan negative of pi over 2 minus theta. Tan is the same as sine. I can put the negative sign outside. So it is negative tan of pi over 2 minus theta. Then tan pi over 2 minus theta. If you go back here, tan pi over 2 minus theta is equal to what? Cotan. Thank you. So here I will write cotan theta with negative sign, which I want now to prove. Now here in problem number 3, solving a trigonometric equation. What are all the values that satisfy sine theta is equal to sine pi over 2 minus theta? I want to put all the values that satisfy this equation. Now, sine theta, sine pi over 2 minus theta is the same as from the cofunction identities is the same as cosine. Now, when the values of sine equal cosine, if you divide here by cosine and here also by cosine, what did you notice? Sine over cosine is tan of theta is equal, cosine over cosine is 1. What are the values that tan theta here is equal to 1? If you go to the calculator, the unit circle, and also the tables that I gave it to you, you will notice that at the angle of pi over 4, the tan is equal to 1. What also? If you go to the unit circle here, I want a positive sine over positive cosine, give me 1, or negative sine over negative cosine, which is in quadrant 3. So here we have 45, here we have 180 plus 45, which is what? 225, or 5 pi over 4, I think. So you can write it as pi over 4 and 5 pi over 4. These are the solutions where tan theta equal 1. Now, number 16 here. Here we have, I want you now to solve this equation. Cosine pi over 2 minus theta. Cosine pi over 2 minus theta. Is it the same as sine? Yes. So it is the same as sine theta equal to cosecant. It is 1 over sine by cross multiplication. Sine squared of theta is equal to 1. Now, do you remember when I told you in the first semester that if x squared equal 1, so the meaning of it that x, it could be 1 or it could be -1. Bravo. Here it is the same as, so here it is like sine of theta, it could be 1 and it could be -1. What are the values of the angle, or what are the angles that sine of it is 1? 90 degree over pi over 2 as a radian. And sine of it is -1. Go back to the table. You will find that is 270 degree or 3 pi over 4. Number 19 now. Tan squared minus secant squared is cosine negative theta. Can you solve this equation and tell me which are the angles that solve that say that is correct? Tan squared minus secant squared. These are one from the Pythagorean theorem, that's equal 1. So 1 is equal to cosine negative theta. Then cosine negative theta. I will drop the cosine outside. So it comes as, look, as cosine theta is equal to 1. Cosine theta equal 1 at which values? At only one value, which is wait. Tan squared minus secant squared. It is here, it was secant squared minus tan squared is 1, but tan squared minus secant squared is -1. Okay, so which values that cosine theta is equal to -1 at pi theta equal pi or 180 degree. Now this is your homework. Exercise 8, 11, 18, and 21. Thank you for listening.